Hello everyone, wonderful. So we are connected, hello. And this is YR, good evening everyone. I mean, if it's evening for you around here, if it's afternoon or maybe good morning, depending what time you're watching. I have here with me today Klaus and Anna from the University of Copenhagen. Thank you very much for being here. They're our speakers for tonight. And I would also like to say thank you for everyone that is watching. And also thank to our sponsors tonight that we're starting with the new sponsorship from Jumping Rivers. There is an analytics company passionate about data and machine learning. And yes, so I guess we're ready to start talking about reporteR for tonight. And so Klaus and Anna, the floor is yours. Thank you.
Thank you very much. So my name is Klaus and this is Anne, and we will be doing this in a collaboration. So I will start to give a small introduction to our package, and then Anne will take over with all the nitty-gritty, interesting computer details later on.
Yes, and I will hide until then. So.
So one thing that we often realize at one point in the process where we are working with data is that errors creep in, not necessarily just coding errors, but also errors in the raw data that we are working with. And for example, here we have, we've been promised that we should be talking about the reporteR package, but possibly this is a mistake, and maybe it's not the reporteR package, it's some unknown label that has snuck in some way, and maybe it should have been the dataReporter package or some other package that we really wanted to talk about. And these things happen, and they happen all the time when we are working with real data, where we need to figure out at one point how should we actually go about checking whether or not we are fairly confident that we can believe in the input data that we use for our subsequent data analysis. And this is what the dataReporter package is really all about, trying to help facilitate communication about the data screening process. So we try to capture, at least have the option to capture most of the potential errors that might be in a data set, or at least facilitate a discussion about whether or not we believe that the input data is real or not. So let me try to give an introduction to a real data problem that Anne and I have been working on a couple of years ago. So it's a Danish study called the Rescue Project, and it is the purpose of the project was to try to evaluate how the treatment of alcohol use disorder are being treated in Denmark. So the treatment that we actually provide patients, does that work or doesn't work? So that was the overall purpose of this project. And fairly early on in the process, after the data was starting to pour in from the people who collected the data from the patients, we had an example like the one that I'm going to show you here. And the main registrations of people who are working with alcohol users is the timeline follow back registry or type of registrations. And that is that you take the patients and they all have an alcohol use disorder, and you ask them how much alcohol did you drink yesterday? So that is the first column that we see in the data frame here. The day one and row one is for patient one, and row two is for patient two, and so forth. So for individual one, yesterday, that person had 20 alcohol units, for example. So that could be 20 beers. And then we can see that we have some missing observations. So for day two, so that is the day before yesterday, 2 days ago, we have missing information. And the 3 days ago, we also have missing information. And we needed to discuss with the people who actually knew about the data collection process, how we should handle these missing observations. And once we got the data here, we said, okay, that's interesting. Why is that person missing from day 2 and day 3? Why don't we have that information? And they say, oh, it's really not missing. It's just because people who have a problem with alcohol, they usually drink in a pattern. So that means that they are drinking roughly the same amount of alcohol units every day. So instead of having to write in 20 every single day, we are just writing 20 for one of them. And then if you have a missing, it means copy the previous piece of information. So this missing that we have here should essentially be 20, but they didn't want to type it in. And this missing observation that we have here should also be 20, but they didn't want to type it in. And if we hadn't had the discussion with them about what we should do about it, we would probably have used some kind of analytical method that would accommodate the missing variables in some way, the missing observations. So once we had the discussion going with them about the missing variables, they said, "Oh, but notice here the 99. That's a missing. That's because we don't know that person, what the amount of alcohol units that person was drinking at that point. So we've encoded that with the 99." And we had a discussion with them saying, well, how were we supposed to know that if you hadn't told us at one point? We would probably just have gone with the observations and used the numeric value and analyzed the data as we saw it, and would have ended up with quite biased results in the analytic part of the whole process. And they said, yeah, that we can see that's a problem, but surely no one is drinking 99 units of alcohol in a single day. So that is clearly not something that is out of this world. And that's the code we use for missing. And that's perfectly fine. And then we went back and tried to recode the data in a way that was consistent with the information that we had just been informed about. And they said, okay, well, if we go further down the data set, notice there's also an 88. Oh yeah, but that's another missing variable code. So that means that it's missing for some other reason than the 99. And the whole purpose of this was just trying to illustrate how we need very precise information about the data set and the data collection process from the people who are actually doing the data collection, and also who know something about the scientific context of what we are trying to analyze. Because we may not have a realistic idea about what a reasonable number of alcohol units in a single day might be, and we can only try to capture this kind of information if we have people who know something about the context and the specific field, if they are helping us trying to identify the potential errors that we haven't even thought about trying to find in the data set. So after doing a bit of cleanup here, we were quite happy, and then we tried to summarize the number of monthly alcohol units that each of the individuals in the data set were drinking. And on the x-axis, you have the number of alcohol units, so it's roughly the number of beers that have been taken in by the patients over a full month. And you may notice up here towards the right that we have a single individual who had about 1,200 alcohol units over a full month. And we said, haha, we found another mistake, because this surely seems like a very extreme number, and certainly compared to the range of the remaining data sets, the remaining alcohol units. So those 1,200, that's a bit excessive. And they said, yeah, it really is excessive, but that's a true measurement. We actually know who the person is, and that's a person who had about 40 alcohol units per day for the full month when the study started. So that is an actual observation. And for us as statisticians or data scientists, we would have no way of knowing what would be realistic or reasonable measurements for the different variables in the data set. So we wanted to have some sort of tool or mechanism that would help us improve the overall data quality in this project and also in other projects by allowing us to have a discussion with the clients about the data. Because when we sit and work in front of the screen with the data, we can obviously make plots or graphs or tables that will give us some information, but we need experts in a given field to assess and evaluate whether or not those values are reasonable or not. And in some cases, we are able to come up with reasonable evaluations or assessments, but in many cases, we might not be. So this should be a collaborative effort between the field expert and the statisticians and data scientists. And this is what the dataReporter package is all about. So let me show you some examples. But before we go to the example, let's recap what we actually mean when we talk about data quality. So when we talk about data quality, there are various aspects that we could consider. For example, we don't want that individuals are duplicated in the data set, so you should only be included once. And we also want to make sure that the data that we believe that we have collected also corresponds to the data that we actually have collected. So we have an idea about what is missing and why, and how many we should have had if the data collection process had been as perfect as we would have wanted. And also if you have measurements where you have informations across variables, so you might have weight information on individuals, and you might have their height, and you also have the BMI variables. You want those to actually match up in the sense that if you have a column with the body mass index variables, that they correspond to the way that you would compute the body mass index from the weight and the height information in the data set. So all of those parts are integral to assessing and determining the data quality in a data set. And some of them you can only gauge by being a field expert or have intricate knowledge of the data collection process. But there are some of the things that we can help out with as statisticians or computer scientists or data scientists. And that is in particular with the validity. So whether or not the variables have the right type and format, and possibly also the range, and also the accuracy, whether or not the data reflects something that seems reasonable in the real world. So for example, if I have an individual with a height of 5 meters, I have a pretty good guess that there's probably something wrong with that registration at one point. But the thing about the validity and the accuracy is that it's easy to set up a bunch of rules that you can use to check against the dataset if you know which rules to set up. But in some cases, you may not even contemplate the potential errors that might pop up in an actual data set as part of the data collection process. And you can only guard yourself against the things that you can guess that would happen, but the unknowns, you really want to try to see if you can identify them in some way. And this is where the package comes in. So the design idea for the dataReporter package is that we want to have something that the data scientist or statistician can produce in the same way or format that he or she would normally do it, but also have something that would enable the field expert, who may not be an R user, enable them to be part of the discussion. And also we want to make sure that it is reproducible. So if we are making a set of checks of potential errors in the dataset, we want to make sure that we can come back in half a year or in 2 years and figure out what did we actually check, and also more specifically, are there any things that we haven't checked in the dataset that we should have checked 1 year ago or 2 years ago. So we want to have something that is reproducible and is easy to provide as a documentation for the parts of the process that was used to screen the data. And the dataReporter package is producing in the most basic way. It is producing a report that can be used as a discussion for the variables in the dataset, whether or not the information contained in those is reasonable or not. It can also be used more interactively, and Anne will show you some examples on that later on. So the dataReporter package is not a cleaner. It's not cleaning or doing anything with the data except producing a report, because we believe that if you want to clean the data, it should not be an automated process by a computer. It should be a human being who makes decision about what the specific choices should be, and it shouldn't be automated. So you need to fix the potential errors later on in the data quality process. And it's also not a formal rule validator. There are a couple of very nice R packages that does that. So if we can set up a bunch of rules, you can either write that in base R, but you can also use some of the existing packages that makes it easier to set up a bunch of rules about the classes or ranges of the variables in the dataset. So we are trying to figure out if there's anything that is peculiar to the data where the field expert or the statistician data scientist is looking at the data and say, oh, this is strange. I wonder if that might be an error or not. So that's the purpose. So let me show you a brief example here. This is an example data set that is part of the package. It contains information on some fairly recent US presidents, and this shows you some of the variables that are in the data set. And let's toy along with the idea that I've been given this data set, the president data, and I would like to figure out if I see something that is strange in that data set in some way. So the way to try to run the basic version of the dataReporter package is, of course, to first of all install it and get the data, and then run the make data report function. So that is the primary function for the end user in this package. So I'm feeding it a data frame, and I'm asking it to produce a data report. And the default setup, you can specify a bunch of arguments on how to modify the type of report. But the default setup produces a PDF file with a report that contains information on the overall data frame and also information about each of the variables in the data frame. So let me show you some examples here. So the PDF file that is being produced when you feed the data frame to the make data report function starts by giving an overview of the data. So in the president data, we have 46 observations, 11 variables, and there's a bunch of checks that are being part of the default package, and we can see them towards the bottom here. So it's documented that, for example, we try to identify whether there's a prefix or suffix white space in characters and factors and labeled variables, but not, of course, for numeric integer or logical or date. So already by now we have information about what did we check, and also the stuff that is not here is the part that we didn't check for. So we know later on whether or not it's something that we've considered at one point or not. So the next page of the output PDF file gives a summary of each of the variables. So here we have the variable names, the classes, the number of unique values that is present for each of the variables, and also the percentage of missing. And if you have a cross in the right-hand column here, that means that there is a potential error, not necessarily a problem or an error, but a potential error that a human being should consider at one point to check whether or not it's actually a problem or not. And then after those first couple of pages, then each of the variables are being taken one by one and being presented and checked depending on the type of variable. So for example, the first name variable in the data frame had a class of name, and that is not a standard class in R, so it doesn't know how to handle that, and you would need to specify a custom function for that. We can also see that the order of presidency, the first president, the second president, and so forth, that's a key in this case here. So there's a distinct value for each of the observations, and it's a character or factor variable. And then for some of the standard class variables in R, for example, the birthday here, we can see that is a date variable, and we get a bit of information about the number of missing and the number of unique values that we have, what the mode is, the minimum and maximum, and the quartiles in this case here. And also it tries to run some of those basic default checks that were shown in the beginning. So it tries to check if there's any potential outliers here. And for example, it has identified, as you can see towards the bottom, that there is a possible outlier with the birth date March 1st, 1300. And that it doesn't say that this is an error, but it enables us to check whether or not we think that is reasonable or not, and we can go back and try to correct it later on in the process. And we also get a graph showing the histogram or the bar plot of the relevant categories for each of the variables, if that makes sense. So here's another example to show some of the checks that are part of the default setup in Make Data Report. So one thing to notice here is that it also checks the labels that we have in the data frame for a character variable like the state of birth. So you have New York, where York is spelled with a small lowercase y, and you also have New York where York is spelled by the uppercase y. And it doesn't say that this is a problem. It might be correct and it might not be correct. It's just something that the package is noticing, that these two labels seem to be almost the same, but there might be a case problem with those, and it just wants to flag it down and point the attention in that direction. As the final part of the report generation, there's information about who actually produced it, when was it produced, which directory was it run from, what was the actual call with all the arguments. So you have that information if you want to reproduce the final report on the same data set at a later date. The final thing that I will say before Anna takes over is that the Make Data Report function produces this report that you can hand over to the client, and you can have a discussion with the client and go through each of the variables and have their opinion about whether or not he or she thinks that those values and numbers and graphs if they seem reasonable based on their knowledge about the field. And once all of this is done and you have manually cleaned the errors and say, okay, this is good enough for us to use in production, there is an additional function called the Make Codebook that will produce a smaller document with a bit of information that you can give to other people who are going to be working on the data later on. So they have a paper or PDF copy of information about what the variables in the data sets are and what they could expect for the type and reasonable ranges. So you can use the Make Data Report early on in order to try to screen and find possible errors, and you can use the Make Codebook once it's all done and finished as much as it can be, in order to produce something that you can use when you actually start to do the analysis later on. And with that, that was a very brief overview of the main function in the Data Reporter package, and it will now tell you all the interesting bits about how you can actually use the specific functions.
Let's see if I can do that. Here we are. Okay, so I want to talk more about how we go from a data set to this report. So what happens here in the middle? And the idea is to give you a bit of information about how it's implemented, so that you will also be able to tweak it yourself and make it more suitable for your data needs, because obviously our choices are not the best for everybody. Okay, so here's basically the structure of how Data Reporter works. Your input is a data frame or a table or a matrix with data, and then your output is a report. And what happens is that it's going to look through all the variables in your data set. It's going to start just with one, and then it's going to start by checking if this variable is at all suitable for inclusion. So we saw before that two variables were not really dealt with by the Data Reporter package, because one was a key and one was a variable class that was not supported. So this is the check that happens here. If they're not supported, we skip them, and then we go to the next variable up here. But if they are supported, well, then we have 3 different steps of data documenting and checking, which is to summarize the variable, visualize it, and check it. And then when we've done that for one variable, well, then we keep on doing that until we have no more variables. And then we pack everything up in a Markdown document and we render it to a PDF or a Word file or a HTML file. Okay, so this pre-check step, which is the one that happens here, where we check if it's suitable for inclusion. Well, the idea is that we don't want to put everything in a report. The keys we don't want in there because there might be problems with privacy if we put that kind of information in there. We also don't want to try to summarize variables where nothing really is going on. So we don't want something that's singular in that sense. And then we have implemented also a check for whether the class of the variable is supported by the dataReporter package. But you can also add more, and you could implement your own extra check functions if there's something specific you don't want in the report. Okay, so just to reiterate, this is where we see how it looks like if something doesn't pass the pre-check, so it doesn't get summarized and visualized and checked, like this and this. But okay, let's imagine that we have a variable that actually goes through this first step, and then we want to summarize it, visualize, and check it. And these are the 3 steps that sort of produce the output that you've already seen. In the summarize step, we try to just describe what's there in the variable. This is where we have information like the minimum and maximum and mean and how many missing values are there and that kind of stuff. Then we also want to visualize it because it can make it a bit easier to see if the variable is distributed as we would expect. And finally, we want to do these checks where we look for specific problems and we try to find out what values in the data in this specific variable are problematic in some sense. And as Klaus also said, we choose which summaries and visualizations and checks to do depending on the class of the variable. So that's what you would get if you use a class function in the variable. So just to show you an example, here we have one of the variables in this precedent data. It's the number of years they were presidency years. And if we check the class of it, then we see that it's a numeric variable. And for numeric variables, there are a number of default checks and summaries and a visualization that we then produce when we do this data report. So first of all, we should note that it will pass this pre-check because it's not a key, it's not a singleton, and it's not unsupported. And therefore we get something like this. And here we have a summary, and this is what comes from the summarize step, where we get the type of the variable, number of missing observations, number of unique values, median, that kind of stuff. And these are all summary measures that are somehow suitable for this kind of numeric variable. Then out here, we get a visualization. In this scenario, it's a histogram. And finally, we get the results from the checks that are chosen for numeric variables. And here we see that it checks for missing values, and it finds that someone has infinite as their presidency years, and it flags that. And it also shows us we have some outliers that we could also worry about a bit. All right. If we want to see what options are available here for the summaries, well, then it's all, I think of it as a bit self-contained in the sense that there's a function in the dataReporter package that's called all summary functions. And if you run that, well, then you just get a description of all the different summary functions that are there that you can choose to use or not to use for your variable. And they come with a name, a description that tells briefly what they do, and then also recommended classes of variables that you can use them on. So for instance, here we have a summary function called countMissing. It computes the proportion of missing observations, and then it says basically that you can use it on all types of variables. Just to show a different example, there's this one that's called refcat, which finds the reference level, but that's only really suitable for factor variables. So it finds the first value, so you can easily see what is going to be the reference category if you do, for instance, a linear regression model. In the same way, you can also find all the visual functions that are implemented by doing all visual functions like this. And you would see that there are 3 different modes of doing plots. There's this basic visual, that's BaseR graphics. It does histograms for numeric variables and bar plot for categorical ones. Then there's the standard visual, this is the default, which does also histograms and bar plots, and it uses ggplot2 to do it. And then finally, we also have this table visual that does distribution tables, but that's only really suitable for character factor labeled kind of variables. Okay. In the same sense, you can also find all check functions that are available by doing the all check functions variable, the function, calling that, and then you can see what different kinds of checks are available. There are a lot of them that start with identify. Those are made for finding problematic values in your data set. So those are the ones that you include in your check step. But there are also some that start with is, and those are the ones that you use for these pre-checks. So is this variable a key? That's not looking at each of the values, but at the variable as a whole. That's a bit of a difference. But the point is that for all of these different functions, you can choose to include them and use them in your data report, or you can choose to skip them, and you can also add your own, and I'll show you a bit about that in a sec. One more thing, now you have the names of the variables here. For instance, there's a variable here called, or not variable, sorry, a function, a check function called identify missing down here. And if you want to read more about that and find out how do we identify missing in that one, well, then you can just use the normal R documentation. You can use the help function, and then you will get information about how it actually does this. So it's all there. There's nothing sort of swept under the carpet. You can see exactly how we do everything in the dataReporter package. Okay. So I was thinking that it might be interesting to see an example of how this runs in practice. So I'm going to try to run an example. And what we want to do here is to make the same report as Claus did, but we want an HTML document instead of a PDF. We don't want any summaries. Maybe we know that information already, or we want something briefer. And then we want to try to use this table visual function for the variables that are of the class character. We only want to see 5 problematic values. Before it printed 10 of them, and maybe got a bit long for some of them. And then we had these name variables that Claus also talked about, which is a special class used in this data set. And we want to treat them as if they were just character variables and hope that that sort of works. And then we want to name our report dirty precedents to be a little bit more descriptive. And we could, of course, also include other things, but this is what we're going to do for this example. So let's see if I can show you. Okay, here we are. So if we want to do this report, well, then obviously we have to load the package first, and we have to load the data set. So I'm going to do that. And then we want to use the make data report function. And then we type in our data set name, so that's precedent data, like this. And then, well, we have a bunch of arguments that are going to help us get our report slightly different from the default. So I'm going to start with the output, and I want that to be HTML, so I just write output equal to HTML. Then I don't want any summaries. I control that using an argument called mode. Oh, here we go. And now I only want visualize and check, and not the summarize mode, which is also one of them. Then I want to use the table visual function for character variables for their visualization. I control that using an argument called visuals. Then I use a helper function called setVisuals. And then I write character equal to table visual. And then that's going to change that setting. I only want 5 problematic values from these checks. I control that using max prop vals. And then I write 5. And then I want to treat name variables as character variables, and I can do that using an argument called treat x as y. It takes in a list, and then I write name equal to character, like this. And the final thing was I wanted the report title to be dirty precedents. So I use an argument called report title and write dirty presidents. And then finally, I'm gonna add an argument called replace equal to true. And that means that it overrides other reports of the same name in the same folder. And I think I need to do that because I run the same code earlier on today. Anyway, we now see it running, and there we go. So it's rather quick. And now it has gone through all the variables and created this, this nice little report for us. Let's see if I can scroll. There we are. And it shows us what checks were performed. Also note that it says here that it has treated name variables as characters, so that's also documented. So everything is still there, and it's quite transparent that way. And then we can see here that we have gotten, instead of a visualization, we have this table now. That was the table visual function. So it counts how many have each of the names. And we can see that we don't have the summary part anymore because we removed that simply. So yeah, what else? Oh yeah, we see down here it doesn't print as many of these problematic values. It only prints the 5 that we asked for it to do. So yeah, that's an example of how you can use it. Let's see if I can get back to my slides. There we go. And there are of course a lot of more arguments you can play with if you want it to look differently. You can also control what summaries and what checks are being done. Okay. But you can also, instead of using it as a report, do something more interactively with it. And each of these summarized visualized check steps, you can also run as a function. Here I show you how to run a function called check on the president data state of birth variable. So that's supposed to be the state in which they were born. And you see here that then it just runs all the same checks that it would do in a report, but now it does it sort of in the console for you. So you can just sit and play around with it if you're not going to hand this over to someone else and you just want to have a quick overview of your data. You can also use each of the specific functions that we've implemented. So here is a check function called identify case issues that we're using on the same variable, and then it gets you this output where it says that you have this case problem that we also saw before. So this is just to show you that you can use them in a report, but you can also use them just one by one if that's better for your workflow. And you might notice here that it's printed in a way that makes it easy to read for humans, but not very nice to work with in R. But I just want to emphasize that if you look at the structure of this object, well, then you see that it has a logical indicating whether there's a problem. Here's true, there was a problem. Then it has this message that it prints, and then it also stores the actual values that were problematic in the same format as they were in the original variable. So you can go find them in the data if you want and change them. Here we are, New York and New York. Yes. Okay, so that's the interactive use. One more thing I've also promised you can do in this package is to add custom functions. So if you don't like or you want something extra from what we did with the checks and the summaries and the visuals, well, then you can also make your own function. Here I have a very simple example. It's a function that counts how many zeros there are in a variable, and you could think of it as a summary function. Maybe that would be interesting. So basically it takes in a variable v, and then it has to have the structure with the ellipsis also. And then it counts how many of the entries in V are equal to 0, and it returns it as a summary result that controls kind of the output class of it and the structure of it. So you can read more about that if you're interested, but the point is this is a very simple function. If you then also use the summary function generator, then you convert it into a proper summary function, then you get a lot of functionality. Here you need to write a description for it and also some recommended classes that it can be used on. But if you've done that, then it pops up if you do like this all summary functions call, then you can see it here along with the other ones. And you can of course also use it interactively if you want to. And then you have this neat little print function, so it prints it in the same way as with other variables. It doesn't just throw everything back at you, it tries to make it easy to read. And you can also use it in the report by setting summaries. There's a bit of syntax here to learn, but it's yeah, it's not that tricky if you have a look at it. You can just add this count zeros function to the summaries for numerics, and then you would see something like this, where you see down here that it has now also counted the number of zeros and just added that into the structure that's already there. So I think it's quite easy to start working also with adding your own functionality. Yeah. But if you want to read more about this, then I have a couple of places where you can have a look. We have an article where we describe report making and interactive use. Note that our package used to have a different name, so there's a different name in that one, but we recently renamed it to dataReporter. But yeah, I hope that doesn't create too much confusion. Other than the name, it should be basically the same. And then we have a very detailed vignette about how to extend this dataReporter package with custom functions. So there's a lot of pseudocode and examples and also general recommendations of how to do that. And we also have been running a 3 to 4 hour workshop a couple of times, Claus and I. And if someone thinks that would be so nice to have that, or they want to teach it themselves, then either ask us for materials or invite us to come and do it once everything opens up again, because yeah, that would be fun. Yeah, and finally, and I guess I need Claus back now. I'm just sharing our contact information here, because if you find something in the package that doesn't really work, please do report it on GitHub. But also, if you have a suggestion for a new feature, a lot of the stuff we've been doing in this package is due to people writing and asking us to do it because they found something that they really needed and they couldn't implement themselves. And then we have a bit of fun doing it. But also, if you write something cool that you think other people could make use of, then please let us know, and then we can include it in the package too. But yeah, I think that's basically it.
Yep.
Thank you so much. That was so awesome. That was really, really cool. Thank you. We got loads of people saying thank you on the chat as well. Like, great feedback. Thank you very much for that. And we have loads of questions as well.
Ooh, exciting.
Yes. Cool. So let's start with Drake workflows. So someone is asking, so Michael is asking, if you have any examples of integration of reporter and Drake workflows.
Do you?
No, I don't have any, at least. Unfortunately not.
Sorry.
Okay, no problem. Then next question then. So the next one is there applications for reporteR for statistical disclosure control, obscuring people's identities from accidental disclosure in data sets?
Well, I think you can implement some of it by using this workflow with the pre-checks to just make it altogether avoid some kinds of variables. But if you need more than that, then I think you would probably want to do it to your data before you enter it into the report. But if you use the way we've implemented it, then it doesn't include the raw data even in your Markdown file. So that means some of these issues you avoid. I think that's most of what we've done in that aspect.
Yeah, so obviously if you have information like the name of individuals or the addresses and you don't realize that is their actual names and addresses, then you might have information that these would be key variables in the dataReporter package. That means that it doesn't print if you have a factor or a character variable where each level is unique. It doesn't print that in the final report. And also one of the default checks that have been implemented by Anne is that it checks for Danish social security numbers.
Sure.
So if you have a Danish social security number or a variable that resembles a Danish social security number, then it doesn't print that. I know that is probably not useful for the majority of the people listening right now, but you could implement your own check. So if you actually had information about the structural format of a specific ID code that is used in a particular country, then you could implement the check, and then it would automatically not print it if you have a variable that matches that specific format.
Yeah, one more thing you can do is to make use of the fact that it uses variable class to decide what we do with each variable. So if you change the class or add a class that says that it's sort of a secret variable, don't use this, then it would automatically skip it if you don't tell it how to support it. So you can also do that maybe to sort of hack your way out of it.
Okay, cool. Thank you. Then we have another one asking about, so how to consider, how would you specify what values to consider as missing? So the person gave an example of like using a -1 as a missing value if expecting a positive only integers.
I don't think I can remember all the rules that we have actually implemented, but I think it should be documented in the package. But so we've looked at all the things that come up in data sets that we're working with. So we look for data for values that are used in other statistical software like Stata, where they use the dot something notation for missing values. Then we look for the 999s and the 888s and any number of 8s and 9s, really, if they're not within the range of the data. So if they don't really belong in numerical data and there's an 888 or a 999 or a -9 or a -8, then we try to flag it. I think a -1 we would probably miss.
But in some sense, that's the whole idea with the package. So if you have a variable where -1 is really a missing code in some sense, then as soon as the client sees that report, the client should be able to say, oh, well, I don't have a value that should be -1. This is actually missing. So then you could hope that you would get the information from the client, and then you would be able to implement a single line of R code that would fix that for you before running it through the package again.
Perfect. Thank you. Very good. And then the next question is, if I'm using HTML outputs, will I have data table from the TT package tables in? Is that not understandable?
We have an alarm somewhere. I don't know, but no. We've had that request at one point if we were able to produce tables as DT tables, so you could sort them and all of the stuff that you might want to do with those in the HTML. I think it is something that we at one point looked at. This is getting a bit vague for me right now, but I think we looked at it at one point and found out that it was not super easy, but maybe I remember wrong.
I think we also discussed at some point that we don't want these documents, they're supposed to document the data. We don't want them to be very interactive so you can change them. We would rather have that you get this one document that you send around and it's the same thing for everybody. But obviously, if this is something a lot of people would want and they would want to implement it themselves, then we would happily accept a pull request on GitHub.
Yeah, we accept anything, almost.
Yeah.
The beauty of open source, very good. Cool. Then I have a question here. Well, congratulations again. And yeah, so is there any recommendation when you're working with large data files, so many rows and many columns, anything that should specify as being best practice to use reporteR with that?
I actually don't think it's a problem, really. I've been working on data set with 700,000 observations, something like that, and also large numbers of variables, maybe a couple hundred. And it's a bit slower, but it's not super bad. I think we have some comments in our article where we give some advice if you do end up having problems with, I think mostly memory issues you might come across, because you produce a very long markdown file, but the way it's done, I think it's rather stable, so it just does it line for line, and then it might crash at some point, and well, it should be okay.
And I know that we tried to crash test it with a million rows at one point, and it runs in, I don't know, 4 or 5 minutes, so it's not that bad in order to produce the report. So, but one thing to be aware of, as Anne also mentioned, is that it more or less handles any number of variables, but that also means that you're going to produce a very, very long report. And the alcohol misuse example I showed you in the beginning, I think we had 600 variables or something like that in that data set.
Sure.
And we produced the report, and it was an 1800 pages long PDF file that we gave to the client that they needed to go through with all the variables, because they had registered a lot of information in wide format instead of long format. So they had a lot of information in different variables. So I mean, it's easy to produce a document, but you should also be aware that it's a human being in the other end who needs to go through it and actually not bore themselves to death by having a very, very long document.
But sometimes there's a point in boring people to death. I really feel like it's a power move when people give me data sets that they haven't considered at all with 1,000 variables or something. I just give them back the PDF and like, oh, but is this okay? Does it look right to you? Because how do they expect me to start actually doing analysis on it if they don't even consider how many variables there are? So that's also a tip.
Cool. Well, thank you for that. Yes, absolutely. And then I have a question here. Someone is asking, so Buba is asking if there's any chance that you could organize that workshop that you gave online.
So we're working at the university and doing a lot of online teaching.
So maybe we will not loathe online meetings as much as we do right now, because I think everyone is super fatigued with the corona situation. So yes, maybe at one point in the future, not in January, that's for sure. So it's really not a problem with the online setup. It's just that everything is online right now.
Yes, perfect. Well, thank you. Good to know that it's a possibility anyway. Thank you. Then can reporteR be used with the validate package for a nice integrated report?
Well, I don't think there's really an integration, and also because the packages do quite different things. So our package goes through the variables like the data set one variable at a time, like column wise, and what they do is go by row wise. So they see if different values for the same person sort of correspond with each other. So they have those very specific validation rules that Claus sort of touched upon. And that means that while our package is sort of one size fits all solutions, theirs have to be very specifically customized to each data set. So we haven't really come up with a nice way to make the two go together. I think they have different goals, and maybe they just need to stay apart. But if someone has a good idea for how to integrate them, we'd love to know, because it's a very nice suite of tools also that have some of the same goals but also quite different.
And you have the option to actually combine the two packages if you are using the dataReporter package more in the interactive sense that Anne actually was doing. I mean, you could just include that as part of an R Markdown document where you don't auto-generate the report, but you're using the same functionality that is available in the dataReporter package and combines that with the validator package, for example.
Yeah, I think we even have an option, so you can easily get a report that you can include as a child in a different Markdown document, so it sort of fixes the header thing. So if you do Markdown, then you can just get your dataReporter report included in a different one.
Perfect. Thank you. And then so Ed Jabu is asking if reporteR is available on CRAN.
It is on its way, fingers crossed.
Yeah.
So we are hoping that it will be in the next week or so that it should be available. So we are not being riplet right now, but we are being partly riplet.
Yeah.
Okay, perfect. Yeah, we just got another question asking when it's going to be on CRAN, so good. Then a cheeky question. So are there any plans to write anything similar to reporteR but in Python?
Well, not by us, I think.
No.
We don't have the skills to do it, but if someone has, and we would love to talk to you about how we implement it in R, and then you can go ahead and do it for us.
I think this seems a little bit similar to Great Expectations in Python, but I think Great Expectations is a little bit more about data validation, and yours is a little bit more about the actual report. So I think that's the biggest difference. But cool, thank you for that. Then let's see if I have any more questions coming. No, we don't have any more questions from the audience, but I have a personal question to you, Klaus, if you don't mind. Second, we have a bus passing by. Yes, so would you like to tell me a little bit more about the R primer? I wanted to hear your
well, if I should be shamelessly recommending my own book, hang on a second.
You always should, right?
Yes, you can.
Well, you asked for it, so no, it's a book that contains it's partly a code book, and you can see the dust on the front page here, so it's not really being used that much. It's partly a code book that was born out of the situation that we have at the statistical consultancy at the section of biostatistics here at the university. So one of the services that we provide is that researchers at the faculty can come and talk to a statistician about their data analysis problem. So it's not working like they will hand over the data and the problem to us and we are doing the analysis, but we can discuss about what they should be doing and how they could go about do a relevant and necessary analysis for their research problem. And in many cases, the students or researchers, they actually knew what they wanted to do. They just didn't know how to do it in R. So, for example, they knew, oh, well, I need to do a survival analysis or a Cox regression or a Bland-Altman plot or something similar to that. So they know the general idea. They just don't have the R skill set. And the R Primer book is a book that provides a bunch of smaller recipes. So you want to do this. Well, this is one way of doing it in R, so it runs through a small example, both with the R code, but also with how to interpret the results that you get out of it in the end. So you hopefully can point your client when you have a discussion or a consultancy and say, you need to do something akin to what is on page 214, because that's sort of similar to your problem, but you need to do it with your data, of course, and modify the conclusions. So that is the R Primer book.
Cool. That seems very practical. I like it. Well, thank you.
Sure.
Let's see. Any more questions? No, actually, I think our time is up. Not a question, but it's okay. It's okay. I save it for later. Well, thank you very much. Thank you for introducing us to reporteR. It was amazing. Thank you. Thank you for everyone in the chat as well. Thank you for everyone asking questions. And again, if you'd like to get in contact with Klaus and Anna, would you like to put again the GitHub address if anyone wants to make a pull request?
Let's see if we can.
If we still have it.
No, we can just try to share the screen again, which should probably be there somewhere. There we go.
There we go. Wonderful. So yes, don't be a stranger. Just make your collaboration. Thank you very, very much again. And well, have a good evening. Thank you.
Thank you.
Bye, YouTube.